Hello everyone! Today I will be teaching you about the science of quantum physics. Don't worry, it's not as confusing as you might think. We will look into the basics of how things work at a miniature level. I promise, by the end of this series, I hope you will understand what happens in the quantum world. In this lesson, we will be looking at particles and waves, the foundations of the quantum world. To start, let's think about this ball and this bowl of water. These objects will help us think about physics at a smaller level using things we already know. What kinds of properties do these objects have? Well, the ball can have a particular mass, position, and velocity. Mass is basically the weight of the ball, and velocity is a measure of momentum in a given direction. Whenever the ball moves, it goes in a given direction with a certain speed and to a specific location. Now let's think about the water. The water has a mass like the ball, but it's different. When moving, water becomes a wave. It flows in all directions. Let's look at this ripple. We can see how far the bands of water are from each other, and we can also observe how high they are from the surface. The frequency is how close the bands are to each other, and the amplitude is how high they are from the surface. All waves have frequencies and amplitudes. The entire quantum world has properties similar to these. Some things are like the ball, while other things are like the water. We call things like the ball particles, and things like the water waves. When we look at the microscopic world, we see molecules and atoms. Molecules and atoms make up everything in the universe. Molecules contain groups of bonded atoms. Atoms are small clusters of matter. Atoms have protons, neutrons, and electrons. Then there's a group of even smaller particles. All of these parts are all particles too. Quantum physics aims to understand the movement of particles and waves. What if we were to move two different particles into each other, or perhaps two different waves into each other? In the case of the particles, they would collide and bounce off of each other. The waves would be much different. Let's look back at our water example. Now imagine a pond in which the water is disturbed in two different places. These waves collide with each other and they create a superposition pattern or an interference pattern. It looks weird, but the waves have essentially fused. The waves interact with each other and they create a new wave. What if we were to make a wave and a barrier collide? For this example, let's look at sound. Sound is also a wave, so it will exhibit the same properties as the water. What happens when you yell in a big room? The sound waves bounce off the walls and the sound echoes in the room. The wall reflects the sound waves back to you. But sound reacts differently if it has only one way to escape. Let's imagine talking into a cone. Somehow, the cone makes the sound travel farther. This is called diffraction, and it happens whenever a wave has to travel through a small gap or opening. The wave goes through the opening in all directions. This, although confusing, is very important in our journey through the quantum world. Waves and particles exhibit fascinating properties in the quantum world. Particles are relatable to our everyday lives, while waves seem to be more confusing and illogical. These ideas are what connect the quantum world to ours. Tune in next time to learn more about waves and particles.